Alright, for this section, we're actually going to look at how to classify and how to name igneous rocks. Right, so to do that, there are two things we need to look at. We're going to look at the texture of the rock and the composition. Right, so to start with, we're going to look at the compositions. So the composition is the suite of minerals or the chemistry of the rock, what it's made of. Right, so igneous rocks are mainly composed of silicate minerals. It's those minerals that are on Bowen's reaction series. So these include olivine, pyroxene, amphibole, biotite, muscovite, potassium feldspar, and quartz plus plagioclase feldspar. So those 8 minerals pretty much make up all igneous rocks. It's just the combinations of those 8 minerals that are important. All right, if you remember, there are 2 types of silicate minerals. There are dark silicates that have lots of iron and magnesium in them, and there are light silicates that lack the iron and magnesium. Right? So if we're looking at examples, darks are like pyroxenes and amphiboles, or light ones are quartz or muscovite. All right? So really, the easiest way to do this is sort of a field classification where you look at how many dark versus how many light silicates you have. All right, so these are all 8 minerals that make up most of our igneous rocks. And these are 4 compositions. We're going to look at them a little bit closer there, but it's kind of general proportions too. So something with lots of olivine is ultramafic. Lots of plagioclase tends to be intermediate. Lots of potassium feldspar tends to be felsic. And if you notice, you have increasing silica, potassium and sodium, increasing iron, magnesium, calcium to the right, and increasing temperature. And these are the exact same breakdowns that we talked about in terms of Bowen's reaction series. So the stuff at the right is kind of your top of your Bowen's reaction series, and you go further and further down as you go to the left side of the screen. So the first one we're going to look at is a felsic composition. Now where this word actually comes from, F-E-L, that's from feldspar, and sic is from silica. And those are both minerals found at the bottom of Bowen's reaction series. So a felsic rock with a felsic composition tends to be pretty light in color because it's got mostly light minerals, very few dark minerals. So if we look at this example here, you can see potassium feldspar, that kind of peach pink color. You can see quartz. In this case, it looks kind of gray because they're clear. And you see biotite. Those are going to be kind of your main minerals you see. Those things at the very bottom of Bowen's reaction series. That means it's going to be really cool temperatures. But because these are the more complicated structures for the silicates, this tends to make magmas that have a very high viscosity. So if you remember, viscosity is the resistance to flow. So if it's a high viscosity, it really, really resists flowing. So it's really thick and it doesn't want to move very much. So think of peanut butter, think of toothpaste in terms of the felsic composition. If we pull up Bowen's reaction series, you can see that the minerals found in this felsic composition rock mainly occur at the bottom. Lots of quartz, lots of muscovite, lots of potassium feldspar, a little bit of biotite, a little bit of amphibole, a little bit of plagioclase. But these 3 at the bottom really are the stars here. Here's another felsic composition rock though. In this case, those crystals aren't very big and you can't see the individual minerals. But overall, the rock is really light in color. You're looking for almost white or a really light gray color. You can see a few little spots through here. These are actually biotite crystals, so it does have some dark in it, but those are begin to rust, which is why you get little red halos there. If we go up to our next one, this is an intermediate composition. It's the most boring name out of all of these, but it's sort of in between felsic and the next one, which is called mafic. In this case, it's got a light and dark color to it. I often say these are sort of salt and pepper, or they look sort of like a Dalmatian. So if you think of a Dalmatian with the, lots of white with big black spots on it, it sort of looks like this rock. It actually helps me remember the name because the name of this particular rock is called diorite, and they both start with D. So minerals you're going to find in here include plagioclase feldspar and lots of amphibole. Those are the 2 big dominant minerals. So if we look at Bowen's reaction series, For the intermediate rocks, lots of plage, biotite, lots of amphibole. These are the sort of minerals you're going to look for. All right. Well, what happens if the minerals are too small and you can't see them? This is an example. So you have kind of a medium gray color. It's not too dark, but it's not too light. Sometimes you'll have like a really dark kind of pink mauve color or kind of a middle greenish color. But it's going to be that middle, really middle of the road sort of colors that we're looking for here. And our next is called a mafic composition. Where the term comes from is the Ma comes from magnesium, and the fic comes from ferric, which means iron. So it's got iron and magnesium in the name. Those tend to make minerals look really dark in color, so that's what you're going to expect is a lot of black for mafic composition rocks. You may see some lighter colored minerals in there, but they're going to be a minority, which is what you see in the rock here. So lots of pyroxene, a little bit of plagioclase, right? But it's sort of the opposite of the intermediate rock, right? Where you had a lot of plagioclase, a little bit of the dark stuff. In this case, it's a lot of dark, a little bit of the light stuff. So if we look at Bowen's reaction series here, for the mafic composition, you still have plagioclase feldspar, but it's really dominated by the pyroxenes and the amphiboles at this point. Now here's an example of a fine-grained mafic rock. So the crystals aren't big enough to see, but you can see the rock itself is almost black. Sometimes they can be brown. Sometimes they've kind of got an orange color because that iron in them can rust if it encounters water. So those are colors you should look for this mafic composition. Now my favorite is the ultramafic. Ultramafic! Alright, so in this case, it's not really, really black. It's green. So this is the stuff at the very top of Bowen's reaction series where it's almost all olivine. That's what all this green is. You can also have some pyroxenes in there, so you can see some darker pyroxene crystals. This is a peridotite you're used to seeing. These are mantle rocks right out of the mantle. The picture on the left, this is actually a pyroxenite rock. So it's almost all pyroxenes without those olivines, but you don't see that as often. You're going to see this one on the right more. The picture on the bottom left is actually an example of a fine-grained ultramafic rock, but you're not going to see it very often, and you're never going to see it in lab or in like a hand sample. It's actually super, super, super rare, but that makes a komatiite. There's your pyroxene, there's your olivine. Now, the other thing we're going to look at, so you have those four compositions to choose from. It's probably not ultramafic, but you should be able to easily recognize that ultramafic rock as you see it. But on the other side, we also want to look at the texture of the metamorphic rock. So the texture of igneous rock. The texture of an igneous rock is the size, shape, and orientation of the minerals. So in this case, texture is not how the rock feels when you touch it, but it's all about the minerals. And I gave you this puzzle piece because as these crystals grow, they grow and grow and grow till they run into each other and run out of room. So you tend to have interlocking crystals that fit really tightly together, just like these puzzle pieces do. All right, so we're going to look at examples of some of these textures. The key to this, though, is going to be the size of the crystals. So here's a picture there for you. Would you say those are small crystals or big crystals? In this case, you can see them, right? You can see that there's clear crystals. You can see that there's pink crystals. That means they're big. So this is kind of how we're going to classify it. So big crystals are ones you can differentiate with the naked eye. So things you should look for are different colors. If you can see different colors of minerals, or if you can see light shining off of crystal faces. Those are the easiest way to tell. So a rock that has really big crystals is known as phaneritic. All right, so phaneritic is also known as coarse grained because it does have big crystals. The phanero is actually a Greek word that means visible, which sort of makes sense because you can actually see the minerals, right? So these form when magma cools slowly. So this texture is found in igneous plutons, such as the batholith that we looked at in the other video. For these phaneritic rocks, I've given you some examples of different compositions. So the two on the left, top and bottom, those are both felsic. They're very light in color, very little dark. On the top right is an intermediate, because it looks to be about a half light, half dark. And the one on the bottom right is mafic, because it's mostly dark minerals. Right, another texture is called aphanitic. So this is also known as fine-grained, because you can't see the minerals in there. You may have a few little crystals, and you can see a few in the top left box, but there's not many of them. Now, the prefix a before a word, such as apolitical, right? That means somebody who's not political. So the prefix a means not. So what that means is, and it comes from that same phanero as our last one, so aphanitic means not visible, which means you can't see the crystals because they're not quite big enough. These are going to cool really quickly, which means you're going to find these as lava flows. So these are going to come back to haunt you when we talk about volcanoes. Right on the top left and on the bottom left, these are both felsic in composition. Bottom right is intermediate, and top right is mafic. Now we have porphyritic rocks. So how are these different than the last textures you've seen? So hopefully you recognize that there are these really big crystals. We call these phenocrysts. And then there's a lot finer crystals. We call this the ground mass. This is a porphyritic texture. So a porphyritic texture is characterized by two different crystal sizes. And this is due to two different cooling speeds. The rock first cools slowly deep underground, and then that magma is uplifted close to the surface and it cools a lot quicker. In this case, this is a granite porphyry because the minerals in there are all fairly large. And here's some other examples. Most of the rest of these are going to be andesite porphyry, so these are intermediate in composition because you've got that kind of nice medium color. Porphyries are actually really important here in Arizona because this is how we find a lot of our copper deposits. They come from these copper porphyries. When we talk about metamorphic rocks, we'll look at these a little bit closer and how the porphyritic rocks end up giving us copper. Now, a pegmatitic rock has got really big crystals. Look at this quartz crystal on the right and the dude behind it for scale. We always sort of joke that the rule of thumb is that to be a pegmatite, the crystals have to be bigger than your thumbnail. So it's a nice, easy way to remember. So the texture is created at the very end of cooling of magma bodies. And at that point, the magma tends to be super enriched in volatiles, because if you remember, those volatiles don't go into the crystal structures. They stay in the magma, and you get more and more and more of it as everything crystals out. And at the very end of it, for some reason, they actually trigger the minerals to grow really big. Now, because these happen only at the very end of the cooling, you only get these pegmatites in rocks with felsic compositions. So on the left there, that's a granite pegmatite. So you're going to see really big quartz, you're going to see really big potassium feldspar, you're going to see really big muscovite, sometimes really big biotite, but that's really about it. All right, let's think about what's in a Diet Coke. What makes sodas so nice to drink? It's that gas that's dissolved in it, right? But what happens if I shake up that Coke a little bit? Then we take the rock off and the pressure gets released and all that gas wants to escape. Well, the same things happen in a volcano because the gas is dissolved in the magma, just like in your Diet Coke, and actually it's some of the same gases like carbon dioxide, but there's also water vapor in magma. So when a volcano finally starts erupting, it's like you take the top of it off, and now that pressure gets released, the pressure drops, and all those bubbles start to expand, and that's when you get this big foamy mess. But lava does the same thing. And when it cools, it traps those bubbles in there. So a vesicular rock has holes due to escaping gas bubbles. There's one particular type of a vesicular rock that actually has so many holes that it's more holes than it is rock, and it makes it less dense than water. And when it's less dense than water, it floats, which is actually pretty cool. All right, so vesicular rocks is pretty easy to recognize because they've got lots of holes. The other really easy to recognize is the glassy texture. So a glassy texture forms when lava cools very fast. It actually cools so fast that it doesn't have time to form any bonds between atoms. So you don't have any minerals in the... So it's actually a glass, just like the glass in window panes. This top left is how you normally see it. So that's pretty common. This next one here, and these down here, these are actually Apache tears. So Apache tears only are these little blobs of obsidian that only come from the Superior, Arizona area. If they're not from Superior, they're not actually Apache tears. Down at the bottom here, these are samples from Hawaii. On the left, these are called Pele's hair. So this is when a really thin stream of lava cools in the air and it falls in these little shards. So it looks kind of like hay or like it would be soft, but those are really thin, fibrous shards of glass. On the right is Pele's tears, and if you remember, Pele is the goddess there in Volcano that controls, or in Hawaii that controls the volcanoes. Over time, those minerals are going to start to crystallize, though, because you're going to start to form bonds. So this is an example of what's known as snowflake obsidian. And those white blobs are where the minerals are finally forming, which is really cool. Last but certainly not least, we have a pyroclastic texture. Now these are going to form from really explosive volcanic eruptions. Pyro, you should probably already know, means fire, and clastic means pieces. So this is pieces of fire. And in these, the easiest way to recognize them is just how mixed up they look. There's big pieces, there's little pieces, you'll find chunks of obsidian, you'll find chunks of pumice, you'll find crystals, pieces of the rock that was along the edges of the magma chamber that gets ripped up. These are a giant mess. And you definitely probably don't want to have been around when these rocks were forming. We talked about the Apache tears up at Superior, because that's in a volcanic area. Those Apache tears in Superior are surrounded by cliffs of this pyroclastic rock. So pretty scary volcanic area. All right, so the texture really tells you about how these rocks cooled and how fast they cooled. So if we want to split these up into rocks that are intrusive and rocks that are extrusive, the extrusive ones are all those ones that cool pretty fast or that come out of volcanoes. So aphanitic, that was a lava flow. Glassy, it cools really, really fast. Vesicular, you've got bubbles being released. The only way to get that gas out of there is to take the pressure off by erupting it. And pyroclastic, because those are big scary volcanoes, you're only going to get those at the surface. That's versus intrusive rocks. These are the ones with big crystals. So phaneritic and pegmatitic are really your two big intrusive rocks. So what about porphyritic? Well, it's somewhere in between the two. It starts its life out as intrusive, but ends up extrusive before it's done. So it doesn't fit nicely into either one of those. So to put all these together, so you pick up an igneous rock, you figure out its composition by looking at the color and the minerals. Then you figure out the texture. And then you go to our handy chart. So you have the chemical compositions across the top, textures down the bottom, and they've got actually a list of dominant minerals for you to help you out. So let's say you have a felsic rock that is phaneritic. This is called granite. So that's where those two meet. An intermediate rock with a phaneritic texture is called diorite. A mafic rock with a coarse texture is called gabbro. And an ultramafic rock with a coarse grained texture is called peridotite. These are the rocks that make up the mantle. Now, if we're going to go to the aphanitic, our lava flows. A felsic lava flow is known as rhyolite. An intermediate is known as andesite. These are actually named after the Andes Mountains in South America. And a mafic is basalt. Now, ultramafic aphanitic is called a komatiite. You're not going to see these. They're super, super, super rare. All right. The only time these were actually forming was early in Earth's history, like over 3 billion years ago, when the Earth was much hotter. All right. So to get a porphyritic word, you just take any of these four up here and then add it to there. So an andesite porphyry or a granite porphyry, for instance, this over here. If you look at the percentage of how many, if you look at the background stuff, that's all andesite. So it's an andesite porphyry. If it's glassy, and it's a big compact glassy, we call it obsidian. And you've probably heard that term. Frothy glass. So if it already has bubbles in it, but it's still kind of glassy, we call this pumice. Interestingly enough, these guys are always felsic, even though they're dark in color. Now, if it's pyroclastic, no matter what the composition is, you can call it tough if it's little pieces, and volcanic breccia if the pieces are all pretty big. Finally, our vesicular rocks. If it's light in color, we call this pumice. So that was that glassy stuff again, and I'll show you a sample in class to show you just how glassy this can be. If it's mafic in composition, nice and dark, that's called scoria. Alright, so if I give you a rock, you should be able to figure out the texture and the composition, and then check one of these charts out to get the name of it.